Hope you're all having a great day so far. Just a little reminder, our first test is a week from today. That's a little something to look forward to. And I hope you remember the somewhat strange strategy for the test grading. Remember, all of the tests are based on this big checklist of topics. And the first test, I hope that you still have this list. You can print out another one if you like on the class website where the homework assignments are. But the list here, you can see like number 8 is the monotonicity criterion, which is what we're talking about today. And then probably not number 9. Well, number 9 should definitely be on the test, maybe number 10, depending on how far we get next week. Yeah, I mean, the test questions, you should expect them to look pretty similar to the homework questions, although I will make sure that there aren't any like weird numbers that you would want to use your calculator for. Does anybody have any vague questions about the test at this point? There's going to be just one question per each of those, 9 or 10 topics, however many there are.
What did you say it was, sorry?
Friday. Yeah, and it'll take up, the whole class time during class. All right, great. And just so you know, I would like you to send it in by grade scope the same way that you send in your homeworks. So you should, it's easiest if you do that on your phones. So be prepared to do that. All right, great. Let's talk then about the monotonicity. This I started describing last time, the monotonicity criterion. The monotonicity criterion is basically about what happens if the voters change their mind in a certain very particular way. Of course, in real life, voters are typically not allowed to change their mind. And so this, you might feel like, what's the point of even thinking about that? But actually, I'll say a little bit later, it is important. And it does mean something about real life, even though this is kind of a hypothetical, unrealistic idea of people choosing their votes. But anyway, this is about what we call boosting the winner. I was describing a little bit about this last time. Boosting the winner. And what I mean by that, I'll say specifically, if we do the election, and of course, somebody wins. So if we do the election and then some people change their mind, some people change their votes in a way to raise up the winner. Right? I'm imagining you do the whole election, and then after the fact, somebody changes their mind, but they do so in a way which just makes the winner ranked higher, all right? And they keep everyone else the same. Keeps everyone else in the same order. What I mean by that is the only change that somebody makes is to move the winner further up in their rankings, and then everybody else in their rankings stays in the same order. They don't also change around the other ones, all right? So some people change their votes to raise up the winner and keep everyone else in the same order. And then this is what I mean when I say boosting the winner. Boosting the winner. All right. How about I use my little highlighter? Huh? Isn't that cute? I know not all of you have highlighters, but... All right, this is called boosting the winner. So, for example, i.e., I should say e.g., that means for example. Like, if A wins, and then, after the fact, someone changes their mind, from, say, their original vote was BAC, and they're like, oh, no, I changed my mind to ABC. See, the A is the winner, and all they did was raise the winner up, all right? this is an example of boosting the winner. There was a winner, it was A, and then after the fact, someone's like, oh, sorry, I changed my mind. I actually, instead of saying, I said B, A, C, but really I meant A, B, C. And your reaction to such a person should be, I don't care because A was the winner anyway. Like this kind of a change after the fact shouldn't matter at all because all you did was increase the stature of the winner, all right? So I will say, in real life, this kind of change shouldn't affect the results at all. It shouldn't matter if somebody raises up the winner in that way. So this type of change shouldn't matter. Shouldn't matter. And this is what the monotonicity criterion says. It says your system satisfies the monotonicity if this kind of change doesn't matter, which is like, it's kind of, in my opinion, it's the natural thing. That kind of change really, it shouldn't matter. But anyway, this, I'll write this as a formal definition here. A voting method satisfies the monotonicity criterion all right, I'm going to use my highlighter. I don't know why, it just occurred to me today. Maybe I should use that highlighter. I don't know why I was thinking about that. I'm going for it though. A voting method satisfies the monotonicity criterion when boosting the winner does not change the results of the election. Right. Because if all you're doing is changing your mind in a way which just raises up the guy who already won, then this shouldn't have any effect on the results. Now, if you're using a strange voting method, I mean, maybe this isn't actually true for all of our weird voting systems, right? Although it seems like it ought to be true for a system that you want to use in real life. But it turns out actually not all of our systems do satisfy the monotonicity criterion. Let's talk about one of them though. How about the plurality system? The plurality, remember that's the one that we typically use in real life, where you just count up how many people are ranked, how many times each candidate is ranked in the first position. Plurality does satisfy the monotonicity. Would you mind if I just write monotonicity? Plurality system does satisfy the monotonicity. We have to demonstrate this by writing another one of our cute little proofs. And as with the other things that we were doing like last time, the proof basically always looks the same. It has the same setup and the same conclusion. It's just a matter of tailoring the sort of typically one sentence in the middle to make it all work out appropriately. Now, in the case of the monotonicity criterion, we usually begin these proofs by saying, like, imagine that somebody is preferred by a majority, or maybe imagine that all the voters rank somebody over somebody. That's the unanimity. This one is about imagine that we do the election and then somebody boosts the winner, right? So I'm going to say something, we should start like, something like, imagine that X wins, and then we change some votes to boost X, right? That is, you change some votes, could be one vote or more than one, so that the only change you're making is that X rises up higher in their rankings. You don't change anything else, all right? And then you got to say something, 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 and your conclusion shall be, thus, X still wins. Because the point of the monotonicity is that if you do one of these boosting the winners, it doesn't change the results, which is to say that winner is still the winner. That's what you have to conclude. All right, anybody think you can fill in the blank? You know, typically, like before, you're going to just write like one sentence in here. You have to explain why using the plurality system, Maybe I should have said that just to be clear. I mean that I'm using the plurality system. So imagine that x wins using the plurality. Sorry, I should have wrote this the first time. Of course, what I'm saying here is specific to the plurality system in this example, and then we could also talk about using some other systems. My conclusion should be thus x still wins using the plurality. Plurality, remember, is specifically the system where all you care about is how many ranks they get in the top position, and whoever gets the most is the winner. Anybody think you can explain? In a brief sentence, perhaps? This is like, when you're doing voting, typically the way we do voting in real life. Is it actually true that if somebody changed their mind after the fact and raised somebody up, they're still going to be the winner? Yes? Can you say some words why? I hope that everybody feels like this is an obvious fact about the way that we do voting. Nobody's saying anything, but in my opinion, this should be obvious. Maybe it's too obvious to say anything.
I said that X would have the majority of votes.
All right. I would not use the M word. Remember, majority means more than 50%, but you don't need more than 50%. You just need more votes than anybody else. But, yeah?
Since X already won, the vote already, boosting, X doesn't change the winner since X already won.
Yeah, you should say something specific about the plurality system. I mean, it may be too obvious to know what to say.
Did you say because X got the most votes?
Yeah? So X got the most votes to begin with, and then you raise them up. I think they still have the most votes. That's what you have to say. Something along those lines. Just don't use the word majority because that means something slightly different. So I would say, imagine that X wins using the plurality. Then we change some votes to boost X. So I would say, since X originally, I also don't like to use the word votes in this context. I'll say it slightly differently. Since X originally had the most, don't say votes, the most first place rankings. In real life, we use the word votes, but here, every vote looks just like a ranking. So it's kind of like every vote has every candidate written on it. You don't really get votes in the traditional sense. But anyway, since X originally had the most first place rankings, after you boost them, they still have the most first place rankings. After the boost, X still has the most. They're like even mosterer now. You might have, when you boost them, you might give them more votes. You're not going to give them less votes, though. And so X still has the most. And thus, X still wins using the plurality. Yeah, so plurality does satisfy the monotonicity criterion. Maybe we can add this into our little chart. So the chart says plurality, the rank choice, the Condorcet, and the Borda. Now it had other columns, but we're just talking about monotonicity at the moment. So the plurality is yes sir, the plurality does satisfy the monotonicity. Because if somebody was already winning using the plurality system, it means they were getting the most first place rankings, and then if you boost them up, they're still getting the most, more than anybody else. All right? Excellent. Could I have you guys try to do the Borda? So the Borda is also a check. This is something that we talked about kind of informally at the end last time, but I would like you to write down a little proof for the Borda. Try it out. Do proof for Borda. All right, the structure should be exactly, maybe I'll scroll up to this. You want to basically write this same stuff. The sentence in the middle should be different because Borda is not about first place rankings. Borda is the one about you add up the points. But otherwise, the structure of the whole thing should look the same. Just you change the thing in the middle. I'm going to walk around and see how you feel. What you say should be about points. That's what Borda is all about. I'm going to write this sort of skeleton up here. All right, you want to talk about this? So you should have started by, as I've said before, you don't have to write exactly the same words that I write, although if you're feeling unsure about what to write, you can, by all means, write exactly what I write. Imagine that x wins using the Borda, and then we boost x. Now what happens? So since you could say, actually you can almost copy word for word what I said here, just replacing first place rankings with points. It's more or less exactly the same idea. I would say something like, since x was the winner, that means they got the most points, because that's what Borda is all about. And what happens when you boost them up? They just get a little bit more points, and so they're still going to be the winner. That's what you wanted to say. I hope you said something like that. Since x was the winner, they got the most points. When we boost x, they gain some points. And actually, technically speaking, you should probably say something like, and also, nobody else gains points, right? You might worry about maybe x got a little bit more points, but maybe because of the change you made, somebody else also got more points, but this is not true. Because of the way that boosting the winner works, you move only the winner and everybody else stays in the same order. So actually some other people will have a little bit less points, but nobody else gains points. When we boost x, they gain some points, so x still has the most points. There you go. That was a little more than one sentence. You could probably say all that in one sentence if you really wanted to. And I will just conclude, thus X still wins. Using the border. All right, the end. Anybody got any questions about this one? That's the border. Shall we discuss the other ones, the Condorcet and the ranked choice? Those are the other ones to discuss here. I'm going to leave the Condorcet for you to look at on the homework assignment, but that is going to be a check mark. So you can write, it's on the homework that I just posted, the new homework this morning, so you should, if you've already checked it out, I doubt it, but it's on there. Anyway, let's talk about the ranked choice. The ranked choice is actually very interesting. I'll tell you why it's interesting. The ranked choice gets a X. The ranked choice does not satisfy the monotonicity. And in my opinion, I've said many times before in class that I kind of like the ranked choice to use in the real world. I think that the ranked choice is better than the plurality, and I would like for us to use the ranked choice in our politics. But this right here is a major sort of red flag, in my opinion, about the ranked choice. Now you have to decide for yourself if you can tolerate this kind of weirdness in a system. This is something very weird about the ranked choice voting, which to me, on balance, I still like the ranked choice, but this is a matter of debate. None of the popular ranked choice haters in our political discourse talk about this, though. I think because it's just too complicated to put in an angry-sounding tweet. It's a lot more effective to just say bogus arguments. There are real arguments to be made, though. Check it out. Here's an example for ranked choice voting and the monotonicity. Remember, if you want to show an X on the chart there, you have to give a specific counterexample. So here it is. Let's say, so this is an abstract made-up example. I don't have like a real-life example where this actually happened. But 5, 4, 3. All right, 3 people say BCA, 1 person says BAC. Of course, like in real life, this kind of example doesn't happen because you're not allowed to change your mind of us. So the scenario is somewhat unrealistic in that sense, but I'm going to say why. It still matters in real life. Anyway, I'm going to do the ranked choice voting here to see who the original winner is. The setup, remember, is you have some original winner, and then you change some of the votes, and something happens to the outcome. So we have to find the original winner here, first of all. And you got to do the rounds. This is the ranked choice rounds. So in round one, we are simply counting up. Can I write my? Oh, this is a slightly weird example. It's fine. In round one, we count the votes up, and we have A is 5 because there are 5. We're counting just the votes in the top position. A gets 5. B gets 3 and 1, which is 4, and C gets 4 up here. So this is 4. And here we have a tie for last place. There is, the ranked choice. You count up the votes, and then you eliminate whoever is in the last place. We have here a tie. Actually, this is something that we've never talked about. This is why I was just temporarily disappointed that this is a weird example here. We have a tie for last. How do you decide who to eliminate if there's a tie for last? We've never actually talked about that. And if you look in real life when people do the ranked choice voting, they have various different rules that are written in the law about what to do if there's actually a tie. In real life, like in a big election, there essentially never is actually a tie because it's extremely unlikely in a really big election. But in a small election, it can happen. Here we have a tie for last place. The standard rules for the ranked choice, if there's a tie, you just eliminate everybody who's part of the tie, all right? Because there's no reasonable way to decide. Should I eliminate B first or C first? Like either way would be unfair to the other person. And so The typical strategy is when there's a tie in the ranked choice, we eliminate them both. In real life, there are some different tie-breaking rules. Like I happen to know in the state of Alaska, the rule is if there's a tie for elimination, there is an official coin toss which determines the elimination, which is a little crazy, but it's true. It's never happened in Alaska, but that's what the law says. Anyway, there's a tie. We eliminate them both, and therefore A wins, right? Because B and C both get eliminated. A is immediately the last person standing. All right. So A is the original winner. Maybe I'll just sort of like do this in my chart just to remind myself that A was the original winner. Welcome. Now, I'm trying to talk about the monotonicity criterion, which is about boosting the winner. So A was the original winner. A is the OG winner, as the kids these days would say. Now, what happens if, so I am going to imagine that the BAC voters, there was actually just one voter. This is the last column. Now, what happens if BAC changes to ABC, all right? A was the original winner. This is a boost of A, and everybody else, you know, the B and the C stay in the same order. All right? So this is boosting the winner. And if they were using the plurality, then this wouldn't matter. A would still be the winner because you just moved them up. Or in the Borda, this wouldn't matter because you just give them a little bit more points. What happens in the ranked choice? So we have to work this out again. So after the change, we have to work out the election again. Now I'm going to write the votes again. They are, I'm just going to do a little copy and paste if you don't mind. It's these same votes, but I'm changing the BACs to ABCs, all right? Like that. Sorry, I'm off the bottom. All right, after the change, everything's the same except for the last column. Used to say BAC, now it says ABC. Okay, and now we find the new winner. See, I mean, maybe it's the same. We'll see what happens. All right, so we got to do the ranked choice again. And this time it goes slightly differently. In round one, A, B, C. I now have A gets 6 because it's 5 from the first column plus another 1. B gets 3 in the third column there, and C gets 4. All right, and so this time B is eliminated. Eliminated B. All right, and now for round 2. Now my votes, after eliminating B, I have 5 votes AC, 4 votes CA, 3 votes CA, 1 vote AC. And when I add the totals, I get 6 for A and 7 for C, and C is the winner. All right, this is what happened. So, can I just refresh our memory? You might get lost in the details here, but remember what happens. The OG winner was A, and then someone changed their votes to boost A, which caused C to win instead. All right, this can happen in the ranked choice. If you're thinking properly about this, this is totally insane that this can actually happen. The original winner was A, and then after the fact, somebody's like, oh no, actually I really like that guy A, and they're like, uh-oh, we better recount the votes. And because that guy said he likes A more, it makes A lose, and C actually wins the election. This is a violation of the monotonicity criterion. So this is backwards from the monotonicity, or I mean, I don't know if I should say backwards. Why I say backwards is because the movement is backwards. It's like you move A up, but in the results it causes A to lose instead of win. All right? This is, I will just say, violating monotonicity. All right? Any questions about that? I hope that this seems kind of absurd and ridiculous to you. In my opinion, this is a major weakness of the ranked choice voting system, is that sometimes an absurd situation like this can actually happen. What it means in real life, like I keep on saying that this actually does matter in reality, even though in real life, of course, nobody can change their mind after they vote. But in real life, in a real election, I will say, we operate as if getting more and higher ranked votes will help a candidate, right? That's how, like when politicians want to win an election, the way you win the election is to convince more people to vote for you, all right? But actually, what this example up here shows, that actually sometimes, like if you were to convince somebody to vote for you in this way, that actually could make you lose sometimes, all right? So in a real election, we operate as if getting more higher ranked votes will help a candidate, but in the ranked choice, sometimes higher ranks actually makes you lose. That's what happened in that election. Higher ranks can make you lose. This is crazy, in my opinion. All right? It means in real life, actually, there are some weird mathematical situations when a candidate might actually want you to vote for the other guy, and because of some weird effect in the details of the math, voting for the other guy actually makes me win. All right, that's the kind of thing that can happen in this case. In the ranked choice voting, sometimes higher ranks can make you lose. All right, this is very weird in, I would say, political campaigns. It means there are some situations in which actually you don't want people to vote for you. You want them to vote for the other guy, which is ridiculous in my opinion. All right, very weird in political campaigns. Now, I've been trying to convince you that this is a totally absurd and bogus thing about the ranked choice voting. The thing that, in my opinion, makes this not such a bad thing in terms of real life is that this, I would just say, is very hard to say if this kind of situation ever actually happens in real life. Like that example that we just talked about is a made-up mathematical example specifically to illustrate this point. And it does illustrate the point that the ranked choice does not always satisfy this monotonicity criterion. But that was a very particular, specific example. And it's not clear if that sort of a thing is common or extremely rare in real life. And it's very hard to tell because in real life, nobody actually is allowed to change their mind after the results. And so this kind of a situation, I think, I would say, hard to say if this kind of situation ever actually happens because people don't actually change their mind and there's no way to tell what people would have said and then what people would say after changing. I'll say, like, if you ask most people, most think it is super rare. So if I was talking to somebody about ranked choice voting and they're like, ranked choice is stupid because it doesn't satisfy the monotonicity, my answer is like, I agree that's a legitimate concern, and it is something that might be very important. But I think realistically speaking, this is not this kind of very touchy mathematical situation probably never really happens in real life. This is my, but that is more or less my intuition. This is kind of like my vibes. It's not easy at all to measure this phenomenon in real life, and so not a lot is known about it. All right, any question? Yeah.
So like for the test, you like ask us like determine if RCD like goes with monotonicity, and then we would do the like rounds and then say it doesn't, like based off on an exam.
Yes.
Okay.
So on a test, unfortunately, like this, in order to, I'm thinking about what to say before saying it. I would say, for example, this would be a perfectly nice test question about monotonicity. Like, give me a proof that Borda satisfies or whatever. This is quite a bit more difficult because you have to come up with this example out of nowhere. And this is a very weird example that is not something that, I mean, if you asked me to come up with this example, it would probably take me a long time to invent this example. More likely, if I wanted you to say something like this, more likely I would maybe give you this example straight up and then say, explain to me why this is an example of not satisfying monotonicity. Yeah, it's hard to invent those examples out of nowhere though. Any other questions? All right, great. This, I think this is all I want to say about monotonicity. So like I said, we didn't talk about this Condorcet, but that's going to be on the homework. And the Condorcet, it does satisfy. It's not so hard to write a little proof about that. All right, great. We have 13 minutes remaining. I think it's enough time to talk about, actually, I want to talk about another voting system, another one, on down another row in the chart. This one is kind of a stupid voting system in a sense. Another voting system. I think of this voting system as similar to the number 0 in arithmetic, where the number 0 as an idea is kind of stupid, like it sort of doesn't mean anything. But if you want to do arithmetic with any amount of sophistication, it is helpful to talk about the number 0, not because it's such an important idea by itself, but just because it helps you to think and to talk about numbers. This voting system is kind of like that. It is called dictatorship. This is sort of a voting system which is meant to be bad, or it's meant to be a very simple system which probably doesn't satisfy any of the fairness ideas that we have been talking about. But it's called the dictatorship method, and here's how it works. This is sort of a stupid example, but mathematicians really like talking about stupid examples. At least start with the stupid examples, and then we can talk about fancier ones. But it is a good thing to have in the back of our mind. So the dictatorship method. Now, in the real life, there are dictatorships in the real world, but they typically don't even think of it as a voting method. It's a little strange to call dictatorship a voting method. But here's how you can make a dictatorial voting method. So this is the dictatorship method. Dictatorship method. Don't do this in real life. Before the election, one of the voters is chosen to be the dictator. How do you choose who's the dictator? It's like who has the most guns, or whose daddy was the old dictator, or something like that's how the dictator is chosen in real life. before the election, one of the voters is chosen to be the dictator, and then whoever they vote for is the winner. That is to say, you ignore all the other votes. All right? In real life, of course, if you're really running your society this way, then you might as well not vote at all. The dictator, you can expect that they will vote for themselves and they will remain the dictator. But this is a way of making a dictatorial type voting system. All right? This actually, in real life, real world dictatorships, they generally present themselves as democracies. Like in North Korea is a dictatorship, but they have elections. They just, when they do elections, there's only one candidate on the ballot, and there's like a guy with a big gun standing next to you looking over your shoulder when you're filling out the ballot. They claim that this is a democracy, and they say, oh, isn't it amazing? Our guy wins with 98% of the vote. It's not a real vote. But anyway, this is the dictatorship method. Before the election, one of the voters is chosen to be the dictator. So can we talk about the dictatorship? You can add this into your big chart. Put this as like the bottom row. And then let's talk about our various criteria. There's the majority, the Condorcet winner, the unanimity. Sorry, I should write them in the same order that you're going to write them. I think I did majority, then unanimity. Is that right? And then the Condorcet winner, and then the one we just did, the monotonicity. All right. The dictatorship, does it satisfy the majority criterion? So you have to remember, what does the majority criterion mean? It means if one of the candidates is ranked in the top position by a majority of the voters, then they are automatically the winner. Is that true of the dictatorship? You have to imagine if one of the candidates, if a majority of the voters put one candidate on top, does that necessarily mean that is going to be the winner? No. Somebody said no. Why not?
Because it's only up to one person.
Yeah, because the entire results of the election are determined by the dictator's vote. And so even if a majority of the people vote in a different way, whatever the dictator says is what the result will be. And so the majority, whatever the majority picked will not necessarily be the same as what the dictator picks. That's why there's an X here. So maybe I'll try and, can I try and write a little explanation about this? The majority was an X, right? And why? It's because even if a majority loves one person, the dictator might choose somebody else, right? I'm sure this actually happens in real world dictatorships. Although it may be, people in North Korea seem to actually love their dictators. But in my opinion, it's because they are extremely misled by their government. But even if a majority wants somebody else to win, the dictator might not choose that same person. And so the dictator's result is not necessarily the same as the result of the opinion of the majority. All right, what about unanimity? Unanimity, remember, it says if all voters rank X above Y, then Y does not win the election. Any thoughts about this one for a dictatorship? This one you have to think a little carefully about. If all of the voters rank some candidate, let's say X above Y, then Y should not win. I think actually this is a bit of a shocker. I'm going to put a little check there. The dictatorship does satisfy the unanimity criterion. Maybe we can just try and write a little proof here. So dictatorship, do you mind if I write dict satisfies unan. Here's my proof. You know, the unanimity, this is what we did last time. I don't know if you remember exactly the structure of such a proof, but you should say imagine, let's say all voters rank X above Y, then something, something, and then you have to conclude by saying thus Y does not win. Remember, it's not the same as saying X does win. It's Y does not win. Any ideas? Can we explain why is it that if all the voters rank X above Y, even in a dictatorship, it means Y cannot be the winner of the election? All the voters rank X above Y. Yeah?
It's only one voter, so if they put X above Y, then that's that.
Yeah, right. You have to remember that the dictator counts as one of the voters. And so if all the voters rank X above Y, this means specifically the dictator also ranks X above Y. And so Y doesn't win, right? Because the dictator did not choose Y. So imagine all voters rank X above Y, then the dictator, who is one of the voters, ranks X above Y. And therefore Y doesn't win, right? Because the dictator calls the shots. Great. So that's why there is a check in the unanimity column. Can we talk about the others? I think, yeah, we got 4 minutes. That should be enough. What about Condorcet winner and the monotonicity? How about the Condorcet winner? Remember, the Condorcet winner means, the Condorcet winner criterion means if there is a Condorcet winner, then they should win the election. So the Condorcet winner would be someone who wins all the pairs. So is it true if there's someone who wins all the pairs, is that person automatically going to get picked by the dictator? I think the answer is no. You could have somebody who wins all the pairs, but the dictator still might just choose somebody else to win the election. So this is also a no, and it's really for the same reason as the majority. Even for the majority, I said even if a majority loves one person, the dictator might choose somebody else. And the same is exactly true for the Condorcet winner. So there's an X. I'm going to try and write that. There's an X for the Condorcet winner criterion. I'll just write more or less the same thing. Even if a Condorcet winner exists, the dictator may choose somebody else. The dictator may choose a different winner. All right? And so that means the Condorcet winner may not be the winner that the dictator chooses. All right. And finally, 2 minutes we can talk about monotonicity. The mono. This is the one that says it's about boosting the winner, right? So you have to imagine you do the dictatorship, you have a certain winner, and then after the fact, some of the voters change their mind to boost the winner up in their rankings, and then you do the election again. Does the winner change or not? If it changes, that means there is no monotonicity. If the winner stays the same, then the monotonicity is satisfied. You want to show me the thumbs, just because we're about to leave? Is the monotonicity satisfied? That means the winner does not change, or not satisfied, it does change. Anyone have an opinion? Show me the thumbs. I see some thumbs. Does the winner change or not? No, I'm asking, is the question unclear? If the winner changes, that means that the monotonicity is not satisfied. If you boost up the winner, I think I see a variety of thumbs. The answer is the monotonicity is satisfied. That means if there is some winner, and then somebody raises that person up on their votes, this will not change the outcome. That's because if you had a winner to begin with, the original winner is whoever the dictator chose. And then somebody says, oh, no, wait, I changed my mind. It doesn't matter. The dictator still chose that winner. And the changing of the mind has no effect on anything. You might say, unless the dictator changes their mind. But the changing is to boost the winner. So the dictator will not move the winner down and choose a different winner. It'll be the same. All right? That's why the monotonicity. I don't have time to write all that, but I said it. I said what I said. All right, have a great weekend.